this is Mr. Coates, and this is APES lecture number 30 on renewable energy. This is part 1, energy from water and wind. So what we have here is one of the largest hydroelectric dams in the United States. This is Hoover Dam. This comes from the Colorado River, and it's right outside Las Vegas. It actually supplies most of the energy for the city of Las Vegas. These things here are called the penstocks, and the water for the dam actually goes into these here and then comes out through the power station down here. So let's get into how water and wind provide us energy. So hydroelectric, that's usually water that provides electricity, so you have to have some kind of structure, usually a large dam. In this case we have a dam, and each one of these is called a spillway, and so the water then goes through the turbines and comes off the spillway. Now the good thing about the hydroelectric power is that it is based on the hydrologic cycle, which will run continuously as long as the sun is shining. It has no CO2 emissions once you build the facility. It has a very high net energy yield because you don't put a whole lot of energy into it after you built the dam. You can also use the water behind it for human uses like recreation and irrigation, and also for water. Problem is, dams are very costly both to build and maintain. They can last a long time, but they can also fail, so there's a possibility of danger there. There are some environmental impacts to dams as well. For example, migrating fish have an issue with dams. A lot of dams are built on rivers that have fish that migrate up the river, and when the fish reach the dam, they can't go any further to get to their spawning grounds. So one of the ways we've gotten around that is that we've built fish ladders. So this is a fish ladder here, and the fish basically jump up the waterfall basically around the dam. And so this allows fish like salmon and trout to get around dams. And so a lot of dams now have fish ladders around them. Another bad thing is that sediment collects behind the dam. When the water slows down, it used to be a river, it had sediment load. And so when it slows down, when it gets to the reservoir, all that sediment falls out and you start filling up the reservoir with sediment. So that can be an issue over time. Upstream flooding can also be an issue because you've dammed up a river now. All the drainage that comes back behind that dam can flood areas back behind the dam. So that's a problem for those people who live upstream of the dam. And then when you build a dam, usually you built it in an area that had some kind of upland habitat. And when you drowned that upland habitat, then you basically leave all that biomass behind to rot in the reservoir. And this can create all kinds of methane issues in the reservoir, as well as CO2 gassing off of the decomposition of all that matter that's left behind. In the United States, we basically have dammed up all the rivers that we can dam up that are really the best rivers to dam. And we really aren't in the place anymore in this country where we can build more dams to get more hydroelectric power. There are other places in the world that are still building dams and have potential, but in the United States, our best sites have already been used for hydroelectric dams. So how does this dam work? As I said before, there's a penstock here, and the penstock allows water then to get past the dam. It usually goes down through the dam, and you have to have gravity here. So the falling water basically then turns this turbine here, and the turbine then turns the generator, and the generator produces the electricity. And then once the water turns the turbine, it is allowed to go on downstream. Like I said, back here we get all kinds of sedimentation. The water down here can be very cold, and this is one of the things that's happened with the Colorado River. When we get into water resources, we'll talk a little bit more about this, but the penstock for the dam above the Colorado River is down in this area, and so the water coming into the Colorado River is very, very cold. Now you can also have small-scale hydroelectric plants. This one, for example, this is called an Archimedes screw generator, and as the water goes from a relatively low area, so you only got maybe 5 to 10 feet worth of height difference here, it flows down this chute, and as the water flows down the chute, it turns this large screw here called an Archimedes screw. And this screw then is attached to a generator which produces a small amount of power. And this power can be used locally. But the good thing about this, you don't need a whole lot of elevation here. You don't need huge structures to maintain. And it can be employed in residential areas because it just doesn't take that much energy. Also, you can actually buy small generators for your own property. If you own some property and you have a creek or a stream that flows through it, and it's got enough force, you could actually purchase some kind of small generating device and produce electricity for your personal use. And so a lot of people are starting to go towards small-scale hydroelectric where they can, and this is a cheap energy source for them. Now you can also get energy from tides. Tides are run by the moon, and so you can create a structure in a tidal reservoir area where as the water goes through it turns a turbine, and the turbine then produces electricity. And so you can get electricity twice a day as the tide goes in and as the tide goes out. Now, one of the things that you have to have is that you have to have a pretty good tidal range. So you usually need 2 meters or 3 meters or above in your tidal range. And a lot of places on the planet don't have that big a tidal range. Here in Tampa Bay, we only have about a meter, meter and a half of tidal range. So tidal power in this kind would not work very well for us at all. One that might work better for us is this one here, where you have underwater structures like underwater fans that turn, and each fan has a generator on it and produces electricity. And now, some of the problems with this is that it may block navigation going in and out of waterways. And so that's always a problem with a lot of these things. The other thing is that salt water is very corrosive. It can be very costly to maintain these things, especially if there's a lot of metal involved. And you have to keep on replacing these metal parts all the time because of that. France is one of the countries that has a very good tidal generating plant, and it's similar to this one here. Like I said, other places are starting to work on these. Wave energy can also be harnessed. There's a couple different types of wave generators out there, but as long as the wind is blowing, we're going to have ocean waves. And the wind blows because the sun shines, obviously. So we could trap that energy somehow. So in this case, you have some kind of structure here, and you need good wave energy for this to work. And as the wave comes in, the water is forced up into this area, and it compresses the air, and it basically turns this turbine, and the turbine produces electricity. And so as long as you have a pretty good wave going in here, you're going to get a lot of air compression, and you're going to get a pretty good turn on that turbine. Now, the other thing that you can have a system similar to this, where you have small little generators in between these joints of this big giant worm looking thing, and then every time a wave comes it bends back and forth, so this part will go up and this part will go down and this part will go up and this part will go down. So all those joints will produce electricity. So these are some ways to collect wave energy. There's several others out there, and they're playing with different methods like floats and things like that as well. The other problem with this is, once again, it's costly to maintain these things and to build them. It's very difficult to build something like this one up here because you have to build something that can withstand the wave power. Waves have a lot of energy to them. If you've ever been swimming in an ocean in big waves, you know this. And to build something like this and try and build this during the wave energy times would be very difficult, and so that's always a problem. Now, there is one major dam we have to talk about, the Three Gorges Dam. This is in China, and this is the world's largest dam. It's about a mile long. It was completed finally in 2012, and it had a lot of controversy. It was the main focus of this dam was to help China get rid of its reliance on coal for electricity. So it does supply a lot of power to 150 million residents. It actually has 32 turbines, and this is quite a lot. If you look at Hoover Dam, I think Hoover Dam has 4. So this one is a huge dam. Some of the problems were when they first started building it, a lot of farmland on the Yangtze River was flooded, and this is pristine farmland that China really can't afford to get rid of. But they did anyway. A lot of scenic areas were flooded. A lot of towns and villages were on the banks of the river in these areas, and they had to move all of these towns. And then some factories were also on the river, and these factories, a lot of these put out some nasty stuff, and so some of that nasty stuff was left behind just to get into the reservoir. A lot of historic sites were flooded before archaeologists had time to get the artifacts out of there. And then displaced 1.4 million people from their homes and businesses in their towns. Like I said, they had to move entire villages out of this area. The other thing that happened is that the Yangtze River was the main area where the sewage for all these villages went, and so the river would flush all this sewage out. Now with this huge impoundment or lake behind the dam, this reservoir is getting stagnant and full of all kinds of problems with sewage eutrophication. It also collects a lot of trash. They remove over a ton of trash a day from behind the dam. And so it's become quite a problem for China. The other thing that they did is that they didn't do very good geologic studies for it, and they actually built the thing on a fault line. Now, this fault line hasn't been active in a long time, but it could become active. And if you have a major earthquake that occurs near this dam, you could break the dam and flood many villages downstream. So here's the dam here, and I'm gonna get rid of me. This is the dam before it was built, and you notice the river here is very, very muddy. The Yangtze has historically had lots of sediment in it already, and this sediment provided fertile farmland when it flooded, and also provided habitat for different fish species. There are a lot of fish that are highly adapted to this sediment load. Well, when they built the dam and it started opening, the sediment dropped. It just basically stayed in the reservoir. It didn't come out, and so now the river is really, really clean as far as sediment goes. And so this is going to be a problem for these areas of farmland down here. They're not going to get that annual flush of good silt and sediment and nutrition for their crops like they used to. Also, fish species that used to live in here that depended on that sediment can no longer do that. And so you're going to see a profound biological change occur behind this dam. Also, navigation now has to go through this lock system. It takes a while for the boats to get through that lock system. So because of that, what they did is that in this part of the dam, they built this huge boat lift. And I think it can lift like 100-foot or so boat up and over the dam, and the dam is like 300 feet tall. It's this huge boat lift in order to contribute to the traffic up and down the river. And so this is for very large boats, and this is for 100-foot and under boats. On to wind power. Historically, wind power has been used for a long time. Here in the United States, we use wind power a lot out west to pump water out of water wells. Also in Europe, they used to use wind power all the time to mash grain. Wind power has been been used very effectively for a long time. But now we're starting to get a little bit more modern. We're starting to find out that, hey, we can use this wind power a little bit more effectively than just for these two uses. So modern wind energy basically turns wind energy into electricity. All these wind turbines here, they have the ability to have a little generator attached to them. And when the wind blows, this generator turns the turbine and produces electricity. And these areas can be multi-use. So you could have a farm underneath your wind farm. You can have a highway here where this is the turbine here, and it collects wind energy on the highway. And you're not taking any more space. And then if you want to, you can even buy wind turbines for your house. These things put out 400 watts. And so you could use two of these to power your house, and you'd be off the grid basically. So there are a lot of things you can do with wind energy. Like I said, Europe really leads the way, although the United States is really starting to come on in this, especially if you go in the Midwest. There's a lot of wind farms in the Dakotas, in Iowa, and Illinois. And a lot of these wind farms are built on current farms, and the farmers get a lot of the profit from these wind farms. And so they're being built quite quickly. In fact, wind is the fastest growing non-renewable energy source in the world. So where is it good to have wind energy? Well, just like I said, in Iowa here, Illinois, this area has good wind energy. You could have some wind farms out here, and California has a lot of wind farms as well. Unfortunately for us down here in Florida, we just don't have very good prevailing winds. We have off and on winds, but they don't really stay around for very long. There are some trade-offs, however. You need steady winds, and that's a problem here in Florida. And if you don't have steady winds, then you need a backup system. So that either means solar or battery or going back to coal. There are other things that go on, a lot of land use with a wind farm. Once again, you can have dual purposes there. It is visually pollution, though. My father, he just hates the look of a wind farm. And they're also kind of loud. They have a lot of noise with them. And then the other thing that could happen with them, and a lot of critics cite this all the time, is that a lot of migratory birds are killed by these things as they spin. And so that could be a problem as well. But that's wind, and I hope you learned something about non-renewable energy from water and wind.